disconnecting the meeting, end the meeting for all. I just that's
okay. Can you mute everyone, please?
Sure, yeah, I will do that. Yeah, see, I'm giving you organizer access. Please just don't disconnect anyone from the GoToMeeting. Okay, fine. So if you have any questions, just ping me. At the end of the session, I will be answering it. Okay, just don't disturb any one another. Now you have the logical diagram. You will just show the relationship between dimension table as well as a fact table. Okay, whereas in your physical diagram you have foreign key, primary key, where you use something called references. So a particular key, a particular column references another primary key column from another table, right? And here you have something called a definition.
Oh my God, Chanakya, I'm not able to see your.
We cannot see your screen.
We can't see your screen, Chanakya.
Okay. And we got kicked out of the meeting, and I just joined in after a pause of 5 minutes. I thought the meeting was done.
Yeah, now I can see.
Okay, I'm keeping everyone on mute. Okay, just you can record from your. Okay. Fine. So, what is entity relationship modeling? ER modeling is generally used in your OLTP system. We don't use ER model in data warehouse. In data warehouse, it is completely called as dimensional modeling. Okay, your ER modeling or dimensional modeling are completely different. The difference being, your dimensional model has dimensions and facts. I'll come to that later. Whereas your ER model, each and every table may be joined with one-to-one relationship or one-to-many relationship, depending on the primary key, foreign key, and you have a lot of tables. There is no concept called this is a dimension and this table should be joined to this table only like this. As soon as you has primary key, foreign key, you can keep adding all the relevant tables in your OLTP system. Okay, because you have so many number of tables to get the information from. Okay. Next. So ER model will always be complex since you do your ER modeling for your OLTP systems. And unfamiliar to business people, incomplete history, you won't have any history information or anything. Slow query performance, obviously, because when you have more number of tables involved, your query performance reduces. Okay. Whereas dimensional modeling has something called dimension table and fact table, where your dimension table stores dimensional information or conceptual information or descriptive information, anything. When you say a dimension table, it may be your employee table which has employee information. It may be time dimension which has time related information. It may be geographical dimension which has your location information, like this. Whichever table contains descriptive information with respect to a particular entity or a object is called a dimension table. You have product dimension. So most commonly referred dimensions are, you have something called product dimension. You have something called time dimension. You have something called promo dimension. Right? The different types of promotions that are available with respect to a product. Okay? And so on. You have multiple types of dimension table like this. Okay. Now, definition. Logical data model used to represent the measures and dimensions that pertain to one or more business subject areas. Dimensional model equal to star schema. I'll explain you what is a star and snowflake schema. Can really translate into multi-dimensional data design if required. Overcomes ER design shortcomings. So we have complexity and all, right? So we are not following any ER model, ER designing here in our data warehouse. Okay. And dimensional modeling advantages are, it is easily understandable, systematically represents history, reliable join paths, high performance because less number of tables are involved, enterprise scalability. Okay. Now we will see the differences between our entity relationship model and dimension model. Tables are units of storage, whereas in dimension model you have cubes as units of storage. Okay. And data is normalized and used for your OLTP system. Data is denormalized and used for your data warehouse and data marts. Several tables and chain of relationship present in your entity relationship model, whereas very few tables are connected in your dimensional model. Detailed level of transactional data is present, whereas summary of bulky transactional data or aggregates and measures are used in your business decisions. Here normal reports in DM you have user-friendly, interactive, drag and drop, multi-dimensional OLAP reports. I'll show you different type of OLAP reports when we start with our OBIEE. We have a very good UI. Here in OLTP systems you can just write a query, get a minor, very simple report, whereas your warehouse, on top of a warehouse, your reporting tool provides very good reporting analysis. Okay.
Chanakya, what is this data normalization and denormalization?
Okay, you don't worry much about normalization because there are different types of normalization again. Yesterday I was discussing and I was telling you what does the normalization do. Normalization removes the duplicates in your tables. Okay. Generally OLTP systems are normalized at 3NF, that is third normalization form. You have something called 1, 2, 3, 4 and 6th normalization form. Generally mostly people will be going with third normalization form. Again when you have something called BNF, Boycott normalization form and so on. There are different types of normalization forms. So each and every normalization form has a certain set of rules. Normalization form 1 says everything should be atomic. That means each data should be divided. Okay. Normalization 2 says it should have a primary key and all those things. 3 is combination of both 1 and 2 has some additional features. And you need not to worry about your normalization form because your data warehouse is denormalized. You have repeated data, you have all the data present in a single table itself. Okay. So what does denormalized do? You don't have all the concepts of your OLTP systems like it should be atomic, it should be separate and okay, it will have repeated data, everything will be stored in a single table. Single table means all the relevant data which is required. Okay. Fine. And we will just see what is a dimension table. Dimension table is one of the descriptive, the business entities of an enterprise represented as hierarchical. So for example, you can say as time, departments, locations, products and so on. Dimension tables are sometimes called lookup or reference tables. Okay, why do we call them lookup or reference tables? Because your fact table will go get some information from there, and suppose say if you want a particular customer and his sales. So if you want the customer name, you go and refer your customer dimension table, right? So that is the reason we are just referring it as a lookup table or a reference table. Okay, but just keep in mind that a dimension table is something which contains very few records. One thing. Second thing is it has the primary keys which the fact table will be referring. Third thing is these tables might get loaded with data on daily basis or maybe on weekly or monthly basis as well. Daily there won't be any much changes to your dimension tables, and your fact table always will refer your dimension tables in warehouse. Okay, these are just a basic idea of your dimension tables. Okay, you can see the characteristics of a dimension table. Hold the dimensional attributes. Usually have large number of attributes. Add flags and indicators that make it easy to perform specified type of reports, and have smaller number of rows in comparison to your fact tables because your fact tables get loaded on daily basis with so many number of measures. So what is a surrogate key? We saw something called sequence. Alright. We created a sequence generator, create sequence, we gave a sequence name, increment by 10, start with 20, right? Maximum value 9999, no cache, no cycle, and we created a sequence. And we automatically populated department ID in our previous practices, right? The same thing, you have something called a row width or a surrogate key in your data warehouse, okay, which is unique, which uniquely identifies your table, like giving 1, 2, 3, 4, and so on. You have something like 100 or something like that, which is a number of mostly it will be of length 10 or maybe 15, something like that, and which is primary key, which uniquely identifies your table, right? And this is automatically populated. This is not from your source system or your any system like that. Okay, this is not from your OLTP system. So any data which is getting loaded into your warehouse is from your OLTP system itself, right? But the surrogate keys and all are directly created from your sequence generator itself. Okay.
So we won't be able to define the surrogate key, right?
Define the surrogate key means?
Means we can't do anything about the surrogate key. It automatically get generated.
Yeah, while creating your mapping itself, you have a sequence generator, and automatically you will populate that using your sequence generator transformation in your ETL. Okay, your ETL itself will take care of that. Okay, so you'll be just using them for joins in your RPD. Okay. Okay. So you can see how a dimension table is defined. You have something called employee ID, employee name, title, and department ID. Whereas you have something called primary key as employee dimension key. This is called a surrogate key. You have employee ID separately. Here in normal OLTP system, you are using directly employee ID itself as a primary key, but you don't use employee ID as a primary key in your data warehouse. You have a separate surrogate key which is being defined. So you are using that key as a primary key, and your employee ID may be repeated also based on your dimension type. Okay, even if it is a primary key in your OLTP system, it is not compulsory that it should be a primary key in your OLAP. Okay, because there are different types of dimensions called SCD type 1, type 2, type 3. So based on the types, I'll just explain you what is type 1, type 2, and type 3 dimensions. Okay, we can just see how this is different from your OLTP system table. Okay, so this is just an example of dimension tables, and you can see a particular fact table is being joined to all the corresponding dimension tables. Like time has a unique key called time key, dealer has a dealer key, model has model key, and the corresponding descriptive information like year, quarter, month, and date. Dealer has region, state, city, and dealer, whereas model has brand, category, line, and model. So you need not to worry which is a dimension table and which is a fact table. So there are different types of notations, right? So by default, _D will refer to dimension table, and _F will refer to fact table in a warehouse. Okay. Otherwise, you will be supplied with a data model which contains the table of tables as well as the joins between them, along with which is a dimension table and which is a fact table. Okay. So as a OBIEE developer, you need not to worry much on identifying which is a dimension, which is a fact. Still, if you have some doubt, blind idea is like you won't have any measures in your dimension tables most of the times. And fact table will have some numbers like 20.2, 20.3, all this. So you can just say that this includes some measures. You can think like that. Okay. Next, we have slowly changing dimensions. Okay, I told you different types of dimension tables are present. Okay, so when I say employee dimension table, suppose say Chanakya Pratap is there, his first name last name is not getting changed. Suppose say we have something called suppose take some example of a girl whose last name changes after her marriage. Okay, so she is still an employee of an organization, and you want to update her last name with the latest changes. Okay, and it is up to you and it is up to your business how to maintain this history. Okay, if you want to go for SCD type 1 or SCD type 2 or SCD type 3, we are not worried. The warehousing team, while designing itself, it will design the data, they will design the table like that, and they will just populate the data on daily basis using the same concept. Okay, can you just give me a couple of minutes? I'll just be back. Okay, just be online. Couple of minutes, I'll be back. Okay. So we have different types of dimension tables. Okay. So we have we'll just see why this concept has come. Okay, for dimensions. But for facts it is not like that, because facts will mostly get updated daily and all the records will come in. Whereas your dimension tables are maybe a few might get updated daily, because your employees in your organization might not come daily and go, right? And few people might not be leaving daily. Okay, so daily you cannot expect the table to get loaded with new data, right? So on timely basis this table will get loaded, and if you want to maintain the history also, so which of the employee has been went away from the organization, or which are the new employees, everything, you can just have a flag. You need not to delete it if you want to maintain the information. Otherwise, if you feel that if you don't want it, your ETL itself will take care of that. Okay, fine. Now, dimension source data may change over time. Relative to fact tables, dimension records change slowly. Allow dimensions to have multiple profiles over time to maintain history. Each profile is separate record in a dimension table. Okay, we'll just see what that profile is, what they are speaking about. Okay, now suppose a woman gets married. Possible changes to customer dimension are last name, marriage status, address, and household income. Because before our last name will be different and now it gets changed, marriage status as well as address and household income, all these values for the column will change. Now, existing fact needs to remain associated with her single profile. Okay. Now the existing facts which already has data for the information when she was not married, it should still be there. But new fact need to be associated with her married profile. If there is any new measure coming in, suppose say a particular employee after marriage, she is taking, suppose say a bank is maintaining, and if it is she is taking a loan of 1 lakh rupees, then after marriage, right? So the new dimension value should get added to this, right? So now you should have your old value as well as your new value. So for the same employee or for the same customer, the customer table dimension should maintain 2 records. Okay. See, her SSN number will be same, her any uniquely identified government proof will be same. But what you do, your surrogate key, there will be a second surrogate key, you will define it as SCD type 2. Okay. And what happens, there will be a second record in your dimension table for the same customer with her latest changes. Okay. And your new fact table will have the second column or the second records surrogate key as the foreign key. Alright. So we'll just see how the values get changed now. So type 1 updates the existing record with modifications, does not maintain history. Type 2 will maintain history. Type 3 will just have a new column and it will have some column called effective date. So from when this new value has been effective. Okay, we will just see, suppose say, let me take out an example of type 1, type 2 and type 3. Okay, see this type 1, type 2, type 3 you are not going to decide. It is purely on business and warehousing team which is going to decide. They will decide it. They will populate the data for you. Our job is take the tables, start making reports. Okay, just keep in mind that there are different types of dimensions. Okay. So when I say type 1, suppose a particular employee, Hari, is moving from Bangalore to Hyderabad location. So we will just see how different types of dimensions handle this information. Okay, so your type 1 will have Hari and Hyderabad as the new location. That's it. Your Bangalore is gone. It is the same record is been updated with your new location. And how does your type 2 will handle this? Your type 2 will have like this. Hari Bangalore from 2010 to 2014. Next, Hari, same employee, Hyderabad, it will say 2014, and there won't be any end date. Suppose this is start date and the end date. You can just imagine like this. This will have information as 2 records, and your employee ID will be same. Suppose say 101 is his employee ID, still it will be 101, and which will uniquely identify this? You will have something called surrogate keys. So suppose say this is like my normal row number itself, 1 and 2. Okay. Whereas in our first type, it will be only 1 record. The same record will keep getting updated. So you do not maintain any history. If a particular value in your OLTP system is getting changed, the same value will be overwritten in OLAP also. Whereas in type 2, you maintain the information like this in your dimension tables. And whereas type 3, what you do? You have something called, it will have only single record again. Okay, you will have 101, you will have Hari, and you will have suppose say previous location as Bangalore, and you will have something called current location as Hyderabad, and you will have something called effective date from when this has happened, 2014, like this. Okay, so this is up to your team, your DW team, how they want to maintain a particular dimension table, and it is up to the business. So they will be deciding it how to have your dimension table, a particular dimension table. Generally, it will be of industry standards. Suppose all banking related tables, they will go with type 1, type 2, type 3 while designing it. When the Oracle or any organization which provides the custom BI apps for a particular warehousing application, they define a particular table as type 1, they define a particular table as type 2 and type 3, they provide you the mappings. Okay, if you are creating any new dimension table, which is very rare, then you have to just confirm with your business and your architect, maybe your architect and everyone, then you have to decide how to handle a particular dimension table. Okay, but as of now, keep in mind that you might have different types of dimension tables which your fact table can refer. Okay.
Chanika, you are going to show the how to design the dimensions. Yes? Type 1, type 2.
No, it's not part of our scope.
Okay.
Okay, we just have an idea how does your type 1 store, your type 2 store or type 3 store data. That is what I wanted to show you. Okay, here we are not going to design any type 1, type 2, type 3 dimension. Here we will be just having an idea how they store data. Okay, right? Okay, next. So what is a degenerated dimension? Suppose if you have your dimension information from your fact table itself, where you can find this in your order and invoice related tables, you have your numbers as well as how much amount has been happened and all. But still, if you want that information to be captured as a dimension information, you take some of the columns from your fact table and populate it as a dimension table. So what is the definition for your degenerated dimension? A dimension which is being derived from your fact table is called a degenerated dimension. That's it. Okay. So even degenerated dimension acts as a normal dimension only. So it will have a primary key, and again your fact table will refer it using a foreign key. Okay. So you need not to worry. So what is a conformed dimension? Conformed dimension has the same behavior across multiple fact tables. Suppose when you say time dimension or location dimension, so with any fact table like sales or orders or revenue or forecast, any fact table will have, time will have the same behavior. Year is always a year to any fact table, right? So year, day, all those columns will be quite common across all fact tables. And location is also quite common across all the fact tables. And you might have extra fact dimension tables again joined to each fact. But if a particular dimension is common to multiple fact tables, it is called a conformed dimension. Okay. And what is a fact table? A fact table consists of measures for business purpose. Fact tables are often defined by their grain. Grain means at what level of detail the data is stored in a particular table. Whether it is when you make a reference to a particular dimension table called time, then you define a fact table like this. It may be present at a day level, it may be present at month level, or even year level. So when you say at month level, you say that the fact table is being aggregated at month level and the granularity is at month level. Okay. And yeah, you can see the definition of grain. The grain means the level of detail represented by a row in a fact table. So in a row, if you take some record in a fact table with respect to a particular dimension, you define the grain. Okay, this is at month level, or this is at week level, or this is at year level, like this. Okay. Now, example of a fact table, you can see that sales facts, and you have model, dealer, and time, which are dimensions, and you have all the foreign keys present in your fact table, along with extra information called revenue and quantity, which are measures. I am taking 10 products, so quantity is 10. Revenue is, suppose say 100 rupees for each product. 100 into 10, 1000 rupees is my revenue. Like this. So all your fact tables will contain measures. Your dimension tables will contain descriptive information, customer name, location, and all this. Okay, fine. So you can ask me a question. What is the just use of without you combining your fact and dimension, your warehousing is of no use, because it is our aim is not to build a report. As a OBA developer, you can think just you have to build a report, but for business purpose, it is not required for them to spend so much money on warehousing technologies for ETL and as well as reporting. So the main target is taking a strategic decision in your business. If your report is not supporting that, then your report is of no use to business, right? Hardly any application will contain 150 to 250 reports. If it is a very complex application, they go with 1000 reports, 2000 reports. But generally what I have come across will have very importantly 150 to 250 reports around. This is like medium complexity applications. So if your report is not supporting any business decision, it is of no use. It should be able to support your business decision. That means when I say business decision, it should be able to tell me in region, suppose say South region, I have $1 lakh revenue. In West region, I have so much. I have $50,000 revenue. And my customer is going for $1,50,000 revenue. How much I can take it from him? Or what are the products that I can improve? So you are firmly taking a decision on your products that you are launching on a particular. See, if you launch an iPhone, you start with US market because there is a good demand for the phones. Okay, and if you go with Indian market, you search for different alternatives, right? Because here we look for a different type of product. So obviously it is all called business strategies. So how they come for these decisions? Based on their history of sales. 2010 I have sold 1000 iPhones here. 2011 I have sold this product here and I made a revenue like this. 2012 I have made like this. And completely all the information about your customer also you will be having in your data warehouse. After all the analysis, your report will successfully show which country is leading for your revenue, which company is promoting your product much. So you will take a business effective decision and you succeed always in the market. Without your history, without your analysis, it's of no use nowadays. Because if you want to start a business, run it, it will successfully run for a year. But over a long run, you should have your analytics or you should have your warehouse. Right? Okay. Now, there are different types of facts. This is not really much important. This is just a terminology called semi-additive, fully additive, and non-additive fact tables. So what is semi-additive? All the values in your fact tables with respect to all the dimensions will be only few columns can be added. Okay, few will have aggregation rule as sum. You have group functions like sum, max, min, all those, right? You have something called sum which can be used against few columns. And you have something called fully additive. Fully additive means all the columns in your fact table across all the dimensions can be summed up. And when you say non-additive, none of the tables have aggregation rule like sum. So you define all this in RPD. I will show you all those while designing our RPD. Okay, this is very simple. Just keep in mind that this is just terminology. You need not to worry much on this. Okay, you don't care whether it is fully additive or semi-additive or non-additive, but just just for our theory. Okay. Next, we have something called schemas in our warehouse. So let me show you a brief idea how our schemas are present. Okay. You have different types of schemas, but in common you will be dealing with two types of schemas, which is called star schema and a snowflake scheme. So when I say star schema, your fact table is present in the middle. And all your corresponding dimension tables are surrounded by your fact, will be surrounding your fact table with primary key foreign key relationship. Okay. Okay, you can go for DIM2. Why it's coming like this? It's going up. DIM3, DIM4. So this is called a star schema, where all your dimension tables are being referred by your fact table. Okay, this is straightforward. And your OBIEE only supports star schemas. It does not support any snowflake schemas. Again, there is a contradiction. It supports snowflakes in your physical model and mapping, physical data layer, and it does not support it in business model and mapping layer. I will show you what is physical, what is BMM, and what is presentation layer in the coming sessions. But keep in mind that always OBIEE only supports your star schema. Even if there is a snowflake present in your data warehouse, that will be converted to a star schema and will be used for your reporting. Okay.
How we can convert into the snowflake to star schema?
Yes. That is later.
Okay.
We will discuss it. Okay, I'll tell you. I'll explain. That comes around 5th or 6th exercise in building your repository. That time I will bring this concept there also. Okay. As of now, keep in mind, If a particular fact table is referring all the dimension tables, it is called a star schema. Okay, and if there is an additional table, one more dimension table, and if there is a join with your dimension to dimension join is existing, if there is another dimension, and if there is a dimension to dimension join existing, it is called a snowflake. It can have multiple dimension to dimension joins. All those are called your snowflakes. When there is a direct join between your fact to your dimensions and there is no other dimension existing, it is called a star schema. And if there is any additional dimension to dimension join, it is called a snowflake schema. So you should be able to convert this snowflake to a star schema in your RPD that we will discuss. But keep in mind that as of now you have snowflakes and stars. Okay, now we'll just see. A schema is a collection of database objects. There is a variety of arranging your schema objects called star snowflake. So your star is a simple style of data warehouse schema, whereas the star consists of one or more fact table referencing any number of dimension tables. The main advantages of star is they are highly optimized performance, okay, widely supported by large number of business BA tools. Now, your star schema will look like this. There is a sales fact table and correspondingly your time, branch, item and location dimension tables are being joined. Whereas your snowflake schema is similar to star schema. However, snowflake dimensions are normalized into multiple related tables. Okay, that is, you have a join between dimension to dimension. Whereas the star schema dimensions are denormalized. Okay, with each dimension represented by a single table. Advantages of using snowflake schema are easier to maintain and increases the flexibility, because for each value, for each type of information you are going with a new table. So it's very obviously it is pretty easy to maintain, and your flexibility with working with database is easy. But disadvantages being increases the number of tables and make the query performance very, very slow because the number of tables increases. So you may be worried why it's simple join, we are not doing anything, it's Oracle server, right? Let it take so much time. Imagine processing information on 1 million records. 1 million is very, very minimal what I am speaking about. It will be 20 million records, 30 million records. When you start performing, for table space itself, you should have around 4 GB, 5 GB and more than 15 GB also. Imagine if one such operation is stuck for 2 to 3 days, how much your query performance and all other operations get affected. That is the reason always you should be worried about your query performance in your warehouse or OLTP system anywhere. Your database should not be dumped up with more number of filters. Okay. And now we can observe snowflake schema. A fact table is been referencing all the dimension tables. Along with it, item table is been referring supplier table. So there is a dimension to dimension join, and location table is referencing city table. Okay. There is an additional join from your location to city. Okay. Your dimension to dimension join is existing. Now, so how will you design a star schema? There are basic principles for it. So one is you have to identify what is the fact table in your warehouse. Okay. Then second is at what grain your fact table is present. Whether is it at detail level or is it at an aggregate level. Then at what are all the dimensions that you want to make a join with your fact table, and select all the facts and identify your dimensional attributes that you can make a join with your facts. Okay. So all these 5 steps you have to remember while designing a star schema in your RP. Okay. Now this concludes our today's session. Okay, we only discussed what is a dimensional model, what is a ER model, what is logical model, and what is the difference between logical model and physical model, what are the different type of facts. Okay, And we saw the differences between star schema and snowflake schema, and we saw how to design a star schema, just the steps. Okay. So any issues, we will discuss it tomorrow. I have sent you the PPTs. You can go